Good morning and welcome to today's webinar. Our topic is managing 3D model data to support AWP and digital twins. We'll first start off with a brief introduction and then quickly dive into what digital twins are and how they're applied using O3's software application. Throughout this webinar, we hope to define what are digital twins, how they're used on modern construction projects, and how they support the AWP process. For that, we're going to do a quick safety moment. So with back to school kicking off mostly around the country here, we want to share a few tips that can help us all stay safe. So important things to keep in mind with young kids on the street and sidewalk: never block a crosswalk. Always adhere to school zone warnings. When flashers are blinking, always stop and yield to pedestrians. Make sure you always stop for the school patrol officer or crossing guard, and then take extra care to look out for children in school zones as they are not always looking for cars. And don't honk or rev your engine to scare a pedestrian, and never pass a vehicle stopped for pedestrians. And make sure you always use extreme caution to avoid striking anyone on the road, and make sure that they have the right of way no matter what. Okay, so now let's just a brief overview of who O3 is. We're a modern web-based platform that leverages advanced work packaging and agile best practices to disrupt the status quo for companies in industrial construction who want to improve productivity, safety, quality, and predictability. Now we're gonna take a peek at Chris McDowra. He is a project manager here at O3 Solutions. He's got over 22 years of experience in industrial construction projects, 14 of those years specifically being dedicated to AWP implementation and process development on projects globally. And as a subject matter expert for AWP, workplace planning, and digital integrations, he's tasked with coordinating and assisting clients along with their digital transformation journey. So let's take a quick look today at the agenda. So first, we're going to go into what are digital twins, and then the different phases of a project lifecycle, how to set up and management of data in O3, training with O3, and how O3 manages digital twins. And then we'll knock out key takeaways, and time permitting, we'll have question and answer. And with that, there's just a reminder: submit your questions throughout the presentation via the GoToWebinar panel, and we will answer those as time allows. And with that, I'm going to turn it over to Chris to take it away.
All right, thank you, Tori. So let's go ahead and quickly dive into what are digital twins. By definition, a digital twin is a 3D graphical model combined with external project information that can be continuously updated throughout its life cycle. To meet this definition of a digital twin, there are four common requirements that need to be met. So first, requirement is a physical object or system. These could be either brownfield sites that are in current operations or plans to build new facilities. The next is a graphical model of an object or system. There's a lot of options out there on the current market, such as photogrammetry, point cloud, laser scan, or 3D design applications. For this discussion, we're going to focus on managing 3D model data and how it's used to support advanced work packaging processes, commonly referred to as AWP, which leads us into our third requirement: managing an ever-evolving set of data related to an asset. O3 does this by dynamically linking project information to 3D attributes within the design model, information to include project schedules, documentation, fabrication data, and construction progress, to name a few. This information is used during the AWP process to package up project information into various package types to support construction's needs. And finally, there is the means to affect or influence the outcomes of project decision-making processes using the data or information supplied. O3 does this by linking all of the relative project data into a common platform so users can draw on this information to make real-time decisions regarding their construction projects. Digital twins can come in many forms, but they're mainly grouped into four main categories. Photogrammetry, ideal for capturing detailed images of project assets. Point clouds, used to capture various points within 3D space to represent 3D shapes or objects. Laser scans, similar to point clouds with very precise measurements. And then we have 3D design models, or 3D graphical representations of design work used during the engineering phase of a construction project. This one is the most common category used in the AWP process and the one that we'll focus on today's webinar. All are considered to be various types of digital twins, but only if they possess the four requirements mentioned earlier. Okay. Digital twins can be applied and used throughout the full life cycle of an EPC or EPC-owned project and are commonplace within the AWP process. As we walk through the next few slides, keep in mind that it's the users themselves that are establishing most of the dynamic links with the 3D model and project information. And it's only a fraction of this information that is required during the setup process. During this setup and configuration stage, we want to align specific data sets and workflow processes for users to use later on in the project's life cycle. Okay. So during the construction and planning phase, sometimes referred to as front-end engineering, FEL stages, or project feeds, digital twins are used to assist in the discussions around improvement upgrades, as well as capturing inspection and visual checks of design and use applications. When both digital twins and AWP are applied during this stage, the project team can easily map out the path of construction and gather detailed quantities that can be extracted from the 3D model to support the project schedules, construction sequence, and cost information, leading to a more accurate project plan overall. O3 provides its users with the ability to convert napkin sketch ideas of process areas and convert them into a defined construction work area and construction work packages. All of this work feeds into a well-detailed path of construction. When providing both the path of construction along with detailed extracts of model data, schedulers can use this information as a basis to build their level 3 project schedules, giving project teams more insight and access to key information than previously. Getting information into and out of O3 can happen one of three ways: through RESTful APIs, where information is shared between integrated project tools, such as material databases, for example, through automated imports and exports using file sharing platforms, or through default templates that are configured for a flat file CSV data import or export into the system. This is all done during the project setup phase when configuring the digital twin. During the detailed design phase of a project, digital twins are used for measurement verification, viewing clashes with existing infrastructure, and to run 4D simulations of project schedules in combination with the 3D model. Procurement and construction uses them to track and monitor fabrication status and material deliveries to ensure that the project team is ready to go to the field. In this phase, the AWP team, along with engineering, begin the on-design process, utilizing CWAs and CWPs laid out in the planning phase earlier. The team can start defining what are known as engineering work packages, or EWPs. These package types are on a one-for-one correlation with the construction work packages and consist of engineering deliverables that need to be defined during this phase of the project. As the EWPs make their way through the O3 system, information is collected regarding the deliverables, the graphical and non-graphical project deliverables, and that information is associated with the 3D model file, and in turn shared with other project systems that could use the information as well. For example, the ISOs that are generated by the engineering process produce deliverables such as documents, PCF and IDF files, and material requirements, to name a few. This information is collected within the O3 software and is used in the construction work package and installation work packages during the AWP process. The PCF files or the IDF files are uploaded into the 3D model to provide construction with a clear picture of what is needed at the work site. The material requirements are shared with a material tracking database that is also fed into the O3 application. It is here where O3 shares project need dates in association with material requirements. This system can do this by combining engineering information, ISO and spool information, the level 3 project schedule, and package start and finish dates to give an accurate arrive on site or field need date needed during the fabrication and construction process. As the project transitions into the construction phase, digital twins are used for material verification or material status displayed graphically, project status visualization, progress measurement, judging accessibility, critical lift planning, equipment sizing, and crew density, to name a few. It is here where the AWP team, along with construction, executes the installation work packages, tracks constraints, and monitors progress data. Also, during this time, they build the testing work packages, known as TWPs, turnover system work packages, referred to as TOPs, and system work packages, commonly referred to as SWPs. These package types are all needed towards the end of the construction lifecycle process. This is done by connecting a combination of systems, whether it be a completion system or a turnover system, with the on-build and on-start portion of O3. This integration shares QA/QC requirements, such as ITPs with O3, that are packaged up into various package types. The data exchange between the systems allows construction, completions, and startup crews to monitor the current progress and accurately predict manpower, duration, project schedules, all within a common O3 platform. But the life cycle doesn't end with the successful startup of a unit or a plant, but rather transitions into the operation and maintenance phases of a project's life cycle. And digital twins are used to assess tracking and maintenance outages, as well as turnaround planning. This process is sometimes referred to as 6 or 7D in some circles. But regardless of the project size, O3 supports the planning initiatives needed during the maintenance, outages, and turnaround processes, similarly as it did with the engineering, procurement, and construction cycles, by connecting client data and systems into a collective platform and sharing that information within an operating plant environment. Okay. Now that we have a good understanding of how and when digital twins and AWP are utilized on a project, it's a good time to dive into the setup and management of O3 projects and how it's configured within the system. With new clients and new users, O3 likes to focus on 3 main categories: data integration, project configuration, and user training during the setup process. For new clients that have 2 or more projects existing within O3, this process moves fairly quickly, whereby we create a project templates, and those previous settings and configurations are transferred or copied into a new project. This bypasses the majority of the work and allows the clients to be more self-sufficient. When it comes to APIs, O3, along with our clients' IM and IT departments, identify the column headers and tables that are needed to be pulled into O3 system. And once this is done, we can capture that API key and associate it, that key with our client's project and set up an import and export rules to pull that data across. For clients that don't have the ability to utilize API connections for their data exchanges, There's also options and that are through an automated import, whereby clients place the file out on the file sharing network, such as BIM 360 Docs in this case, and O3 can be configured to look at files within that file sharing network and pull that data across. Much in the same way that an API works, and like an API, this can be scheduled on an automated process to run in the background on a daily, weekly, or monthly interval. When it comes to setting up user access within O3, we like to set up role-based permissions within the system, whereby the project team assigns users to roles, and those roles have varying degrees of access within the system. For example, if clients choose to bring on a third-party contractor and want to limit the scope of what information can be viewed, updated, or modified within the system, this is possible. With over 65 categories and 450 options for configurations, user access can be as granular as needed. Moving on to the configuration of the project settings, it is here where we're able to structure the workflows and the data in such a way to benefit the project, whereby eliminating a lot of the user error that is commonly found in traditional systems. In our example, we'll be configuring the association sets for construction work packages, mapping out the association types with other project deliverables. Once done, the CWP shares a relationship with contracts, other package types, documents, drawings, mechanical equipment, and the 3D model. So as users are building the CWPs, they're making the associations with other package types and deliverables within the system, dynamically linking both graphical and non-graphical data sets within O3. In the forms and template configuration, O3 uses previously captured data to auto-generate needed forms for various package types, scaffold requests, RFIs, and other related project documents, eliminating the need for manual curation. To do this, O3 uses current project documents in Word or Excel formats and can be configured and populated using the data captured within the O3 system. Now, to meet the fourth requirement of digital twins, users must be able to utilize project data captured within the system to influence the outcomes of decisions within a project. To do this, O3 provides dashboards and reporting mechanisms within the O3 application. During the setup phase, you can choose between various predefined dashboards to create custom dashboards and tailored to your project. With over 25 groups, users can be able to select from 700 predefined widgets, each of which are customizable through various options such as filters, header and footer descriptions, and drill down options, allowing users to see at a glance real-time information regarding their projects or projects in some cases. Depending on the user's access level, they can be able to view this information at a portfolio, project, or discipline level, meaning that I can view multiple projects at a single glance. Training is a vital part of the setup process and one of the focal points that the team prides itself on. As the project moves through the setup phase, clients are encouraged to go through the self-paced training program available within O3. This is to familiarize the users with the layout and functionality of the system, as well as provide detailed instructions on how to complete certain tasks within the system. Additionally, one-on-one training and feedback is provided to answer any kind of questions along the way. If users want to learn more about a particular topic, they can quickly access the system articles written for the most frequently asked questions, or if they want to, they can access a live O3 representative via the chat icon located in the bottom right of any screen. So now that we have a Now that we covered the setup phase of O3, let's look at how O3 manages digital twins and 3D model information. And the simple answer to this is one federated model, applying translation, scale, rotation, and unit conversion into a single file instance imported within the O3 environment. Now, in this example, we used S3D as the 3D model combination of choice, along with TECLA, PCF, IDF file information, to name a few. In cases where you may have multiple engineering houses using different tools and providing different file formats, the same is still true. For example, if I have two engineering houses, one designing in S3D and the other designing in PDMS, and vendor models supplied in maybe CADWorks, for example, these file types can be consumed within the O3 platform. And rightfully so, each engineering house would be also supplying their own TECLA and PCF IDF file information to support their various scopes of work. That can also be included within the O3 platform as well. All of this model information can be viewed as a single source of 3D information within the O3 platform, and in combination with AWP, project controls, material status, make up the base data needed for digital twins in the construction world. Now, you may have picked up on the various different model types that I may have mentioned earlier, but what 3D file types does O3 support? So in total, O3 supports over 70 different 3D model formats in combination with various project-specific information. Some of these are to include Smart Plant 3D, Aviva PDMS or E3D. Then you have Intergraph's PDS, CADWorks, and various other different modeling applications, as well as a wide variety of different CAD software that is able to be published within the O3 environment. In today's climate, where EPC projects are executed using a global initiative, digital twins and AWP have become the gold standard when it comes to projects of any size. Providing projects with flexibility to exchange information in an agile environment is what O3 has been designed to do. Okay. So some of the key takeaways here that we kind of want you to take with you is to make sure that you know that digital twins can come in many forms. Those digital twins can be made up of various different models or model types, and it doesn't have to be very difficult at all whenever setting up a digital twin for your project. So with that, I'll turn the presentation over to Tori to field any kind of questions from the audience.
Thank you, Chris. That's some great information. So here's our first question. How long does the typical project take to set up within O3?
Okay, so just a typical out-of-the-box implementation. What we typically tell clients is, and what we kind of pride ourselves on, is a 4 to 8 week setup phase. During that setup phase, you're also going to have not only data integration, but you're going to have user training as well as testing and configuration of the O3 system. But typically it's 4 to 8 weeks.
Okay. Here's another question. It centers around latency. How big of a model can O3 handle? Are there any issues with handling large data set?
Okay. All right. So O3 uses both the Forge viewer and Azure architecture to interact with project information. So that information is actually stored separately. So you don't have the latency issues that you may have with other systems. We don't write the data directly to the 3D model, but make associations outside of that. Whenever we're actually building the 3D model, we'll go ahead and split that model out into various disciplines. so users can actually draw down just the information they need to see. But typically what happens is doing this, it actually makes the system run smoother, and you don't see a lot of the latency issues experienced with other systems.
Okay, we've got a question here. It says, how many people would have access to O3 and in what departments?
Oh, that's a great question. So the way that O3 is set up, O3 is set up in a way that allows anybody within the project to be able to have access to O3. So what we want to do is we want to make a community platform that the project can utilize. So your project schedulers, your not only your workplace planners, but your construction professionals, as well as anybody else that wants to see that project, can be able to have access within O3. So it's not a user, it's not limited to the number of users, but basically it is applied to the entire project based off of the TIC.
Okay. Here's another one. Is the field weld tracking possible using O3?
We have integrated the 3D or the weld tracking information into the O3 platform. And what we'll do is we'll track the number of welds, that is, if they have a unique identifier associated with them, and we can make that connection with the 3D model.
Okay, and can you export added attribute information within the model file?
Yes, we can. We can extract model information to be used on various different platforms and export it out to different systems. And that's easily done through a CSV file transport and file type.
Okay, let's see what else we got here. O3 uses both a Forge viewer and an Azure Architect. Nope, sorry, I'm reading the wrong thing. What happens if I have a dumb model or a 3D model with limited attributes?
Okay, so great question. In the past, you wouldn't have a digital twin, or you'd have very limited. You'd have very limited options whenever it comes to graphical packaging within a 3D application. Structural steel is a good example because their current engineering work processes kind of run similar to what happened in the past, whereby I would have a engineering model with, I would be lucky to get like a WT type as a model attribute within the system. So I couldn't make any kind of associations with other reference drawings or model status or anything of that nature. But what we've done is we looked at the full life cycle of the structural steel engineering development on an EPC cycle, and we come to find out that that model information is actually stored in the TECLA file information. So in that case, we're able to extract the TECLA file information and overwrite the 3D model file to include that information for the projects. So just, I guess I would say, if you have a dumb file or if you have a dumb model file, to look at the entire process, not just maybe the engineering processes, but look outside of the engineering group to see if we can pull in that metadata into a 3D model file.
Okay. And this will probably be our last question as we're running out of time here. So Chris, do the O3 dashboards have 3D interface?
Not currently, but since O3 does work in an agile environment where we release new updates to our system every 2 weeks, what we do is we connect with each of our projects on a weekly or bi-weekly basis, and we gather that input based off of real-time users using the O3 application, and then we put those as project stories within our Agile platform, and the team pulls those down. So if you have a good use case scenario that we can incorporate into our Agile development, that can be incorporated as well.
Okay, awesome. Well, thank you, Chris. I think that's all we're going to get to today as far as questions. But as a reminder, you can still email us or Chris at o3.solutions, and we'll be happy to address anything that we did not cover today or go into deeper detail if you'd like. So be sure to reach out to us. You can also find tons of resources and information on our website at www.o3.solutions. And stay tuned to social media and our newsletter for our next webinar that should be coming out soon. So with that, I think we're done, and I'll end the webinar for everybody. And thank you again to Chris for joining us today.
Thank you, Tori.